Hello guys, my name is Arun and welcome to my channel. And this is actually a series of tutorials on computer terminologies for high performance computing. Now, the last tutorial we saw some basics about register and cache and how they function and everything. Now today, in this video, I'll be explaining you guys something about cache line and cache miss. Okay. Now, let me explain what's happening. Now, here's the thing. Remember, in my explanation, I told that registers they don't, if they refer to the data from the RAM directly, then it will take a long time. On the other hand, if the data is already available in the cache, then the processing time for fetching the data will be smaller, isn't it? Now here's the thing. Now when the cache, okay, so here's the thing. Now for this to happen, the cache should have the data from the RAM, and how it reads, it has its own mechanisms. Okay, and then what it has its own mechanisms, and one of those mechanisms that explain how it works is called as cache line. It's called as cache line. Some people say it as cache line, it doesn't matter. Okay, as long as you get the concept, it's fine. Now what cache line is as follows. Now cache has its own memory, like as I told you before, it has a memory of 1 to 8 bytes, 8 megabytes, depending on which kind of cache you use, doesn't matter. So what happens is that this memory is segmented or divided into multiple parts, and each part will have its own division. For instance, if it's let's say for an example, let's say let's say the cache is like 2 megabyte, and there are like two divisions, then each division is 1 megabyte long, then 1 megabyte long, let's say. Then what a cache line is, this one, every segment, each segment becomes a cache line. Okay, so this cache, which is 2 megabyte big in memory, has two subdivisions. So each subdivision is actually a cache line, and each cache line has a size of 1 megabyte. So as a consequence, when the cache goes into the RAM to fetch data, it's going to fetch 1 megabyte of continuous successive memories, continuous bytes equal to 1 megabyte, and then places them in each cache line, and that's what cache line is. Okay, the data from 64 to 128 continuous bytes of memory fetched and stored at the cache. That each unit is actually a cache line. I mean, in our example I've told over here, the cache line is 1 megabyte, but that's not usually how it goes. You have multiple partitions and stuff for caches. So the actual size will be between 64 bytes to 128 bytes. Okay, now there are different levels of cache. So there are like L1 cache, L2 cache, and L3 cache. Okay, L1 cache is the smallest of the cache, which can hold up to 100 cache lines. Okay, again, these are just subjective values, and they depend entirely and completely differently based on different processor architecture. One processor might have 3 levels of cache, another processor might have 2 levels of cache, or something like that. So you just have to keep in mind that each these are just some arbitrary values, which you can just arbitrary values, and they differ from one processor to other processor. Next thing is cache miss, and this is really important because sometimes this will be really helpful, and especially if you are optimizing your program. Now what a cache miss is as follows. If you have a value or data, and if you process it, and then they process it, and that value is not available in your cache line, what happens is that you get an information from your processor. The processor will tell that, okay, this data is not available in the cache, so cache, go and fetch this data from my RAM. So that value will go to your RAM and then fetch the data and then writes it in your cache line, and then from the cache line the data will be accessed to your processors and goes on. Okay, so this is what we mean by cache miss. You want some data in your cache memory, and that value is not available, and as a consequence the cache has to go back to your RAM and fetch the data and then come back. And here's the thing. Now how cache works is as follows. Initially what will happen is that this is your cache, this is your cache, and this is your RAM. Let's say let's say the cache line is 64 bits long. So what happens is that, suppose if you're in your RAM you want to access this bit of memory, let's say this is just 8 byte, 8 bytes. Now what happens is that the cache will not take this one alone. Instead it will take 8 byte times 8 memory. So it means for one cache line it will go and take 8 continuous bytes and places them over here, okay, in the first cache line. Why is it? Well, that's how the architecture is defined. Now if you were, instead of taking a continuous, if you go with discrete, then maybe the speed might be reducing drastically. So people, when they designed, they saw that this is an optimal way to look at it, so it's fine. Okay, now now what happens is that, now let's say I have a data over here which is not a part of cache line. Now this data, then let me change the color over here. This data, which I call it A1 will be over here, A1. Now along with that you have extra data over here which will be placed over here. Now all of a sudden this data A2 is not a part of this cache line. Now all of a sudden your processor wants A2, and A2 will check. Now the cache line will be checked, A2 is not available, and then you'll be like, oh god, the data is not available. So your processor will tell, okay, cache, go and fetch A2. So what happens is that this entire line is erased, and then the cache goes to the memory location RAM where A2 is and fetches this data. A2 fetches this data and then extra data along the way. Okay, now this is your A2, no problem. Okay, that looks like A square. This is your A2, no problem. But along with that, your a lot more extra unnecessary data will be along with it. Okay, now if you notice something, while writing this, the already existing data A1 is removed. Now all of a sudden if the processor says, okay, I need A1 as well, and then what will happen is that this line A1 will not be here in this. You get another cache miss. This is cache miss. You wanted data and it's not available in the cache, so the processor fails to get the data from the cache. So it's like that's why it's called as cache miss, and the data is gone. Now the cache has to clean this cache line, and then clean this cache line and then get the data of A1 from here and then write it, and so on and so forth. Now here's the thing. Suppose in an alternate scenario, let's say the data that you want to look at in your RAM, okay, are close to each other, like A1, A2 are close to each other. So what happens is that when you start accessing your cache, when it tries to access A1 and A2, okay, in the first cache line, they'll all remain together. So this is A1 and this is A2, and you can have some extra information over here. And what happens is that the data is just fetched only once, and the processor, if it wants A1, it will just check the line, get it. A2 checks the line to get it. Works on very fast. Remember, the speed between your processor and your cache is very high when compared to your cache and your RAM. So this fetching data will be several times faster. And I can give you some actual values when we discuss about the full detailed functioning of a cache. Okay, so at that time I'll give you guys the thing. So this is what we call as cache miss. Now suppose, the thing is, if we keep the data separately, like together like this, or the array sizes are kept in a proper manner or something like that, what happens is that you avoid cache misses very often. Now this is just a simple data to look at. Imagine if you are working with arrays with which have a non proper sizes, and which have an improper sizes, or just an odd number of sizes or something like that, then the likelihood for cache miss is very common. Cache miss can occur very often. Okay, so that's what you have to keep in mind. So sometimes when you design programs, or when you implement programs, you have to do that in such a manner that you just have to keep in mind that cache miss can occur, and you have to modify them accordingly, so that this kind of issues avoided. So that's about cache miss and cache line. Next tutorial I'll explain you guys some details about server, cluster, latency, throughout, and parallelism. Okay, so thank you guys for watching, and I'll see you guys next time.